Yeah.
Yeah. When you were learning about the monomial, binomial, trinomial, then this terminology was there. That is polynomial. Okay. Here we will be here we will be having the detailed discussion of polynomial. We will understand what exactly is polynomial. All the algebraic expressions are polynomial. Yes or no? Is there any criteria to be a polynomial? That also we will see over here. So the first condition is all the algebraic expression are not polynomial. Here particularly we are going to discuss about polynomial in one variables. So we also have to be careful whatever is the criteria to be a polynomial, and there has to be one variable. So if I am writing x plus y plus z, we are going to say that this is not a polynomial in one variable. Why? Because we can see here like a variable is there, that is x, next variable that is y, other variable that is z. So three different kinds of variables are there. So one variable is not there. So we are not talking about this one. Okay. We are going to talk about polynomial, and that too in one variable. If x is there, only x has to be there. If y is there, only y has to be there. Okay. Now, what is the criteria to be a polynomial? There is only one criteria, that is the power or the exponent of the variable has to be a whole number. Okay. So if I am writing x square plus 2, and if the question is it a polynomial? Is it a polynomial, Sara?
Yes.
Yeah, it's a polynomial. Can you tell me why?
Because it has a variable.
It has a variable and it's fine. Variable is there, that is okay. But the exponent of the variable, okay, the power or whatever you say, the exponent of the variables, okay, exponent of the variable has to be a whole number. It has to be a whole number. Can you tell me what is whole number, Sara?
Like 1 to infinity.
Okay, zero is a whole
0
number.
to
Zero is
uh, yeah.
okay. So all the counting number starting from 0, 1, 2, 3, counting numbers, that those are whole number. Counting number, when you started learning mathematics, then how you started counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then till 100, and then we realize that we can make it by ourselves 101, 102. So these are the counting numbers. Okay. And all the counting numbers starts from 0. All are whole number. So now let's get back to the definition of the polynomial. The criteria is the power or the exponent has to be a whole number. If the variable's exponent is a whole number, then it's a polynomial. Okay, I am saying variable's exponent, that has to be whole number. Number can be any number is there. Let's say this 2 is there. If 2, the power of 2 is minus 2, that is fine. Minus 2 is a whole number, Sara? Is it a whole
No.
number? No. So if any number is there and or constant term is there, that is having power which is not a whole number, that is completely okay. But variables must have exponent as a whole number. If this one I am going to write it like this, x to the power minus 2 plus 2, now it's not a polynomial. Why? Because the exponent of the variable, it's not a whole number. Okay. Now there are few
Okay.
exponent law of exponent which we need to understand. Then only we will be able to analyze whether the given expression is a polynomial or not. Okay. So let me explain what is the law of few rules of exponent is there. Or we can say law of exponent. First, we will understand what is the law of exponent. This rule we are going to apply in our expression, and then we will check whether it's a polynomial or not. So there is a rule that a to the power minus m is equals to 1 by a to the power m. Okay, this is a rule. This is a formula. Okay. What exactly this formula is trying to say, that whenever any number or any variable is having a power, be it a negative power or positive power, if you will change the place, if you will make it sit from numerator to denominator, or from denominator to numerator, the exponent, like, nothing will change, only the sign, exponent sign will get reversed. Let me show you with the help of example. Suppose I am having here a to the power minus m. What is there in the denominator? Nothing. That means 1 is there. Can you see on the other side, I have just taken this a to the power minus m and have written it in the denominator. It was in the numerator. I am writing it in the denominator on the other side. And once I am writing it in the denominator, can you see the sign of the exponent reversed?
Yeah.
Okay. So this is how,
Yeah.
like, this is what the rule says. The rule says that if you are having 1 by 2 to the power 3, and if you want to write this 2 to the power 3 in the numerators part, okay, here it is sitting in the denominator, right, Sarah?
Yeah. Yeah.
If you want to, maybe if you are doing the calculation, maybe for any other reason, you want to write it in the numerator, and if you want to do so, you are allowed to do so. Okay, mathematically you are allowed, but you have to be careful. The exponent will, the sign of the exponent will get reversed. If it was positive already, it will become negative now. What will become negative? Exponent sign will become negative now. If the exponent was positive, it will become negative. If the exponent is negative, it will become positive. When the sign of the exponent will reverse, when we are switching the place, when we are taking a number from the denominator and putting it in the numerator, that if you are doing, then the power will reverse its sign. Power will be same, but the sign will be different. So 2 to the power 3 exponent was positive over here. Here the exponent will become negative. Okay, we have taken it in the numerator, and this is how we can write it. That's what the formula says. That's what the formula says. Let's understand the formula in detail. Suppose I am having, suppose I am having 5 square by 4. Okay, if I want to write this 5 square in the denominator, mathematically it is allowed. Okay, I can write it in the denominator beside 4. 4 will say, okay, go and sit beside me with the multiplication sign, of course. Okay, so 5 square will come here, but here the exponent was 2, and that is positive number. Okay, here exponent was positive. When you have change the place, exponent will reverse its sign. Am I making sense, Tara?
Yeah, but why do you have to multiply 4 and 5?
Because 5 square, we are bringing it in the denominator. So just beside 4, you will write 45 square, right?
Yeah.
Right? To make it clear,
Yeah.
like, to avoid this blunder mistake, we have to show that there is a multiplication sign. 5 is a different number, 4 is a different number. 45 we are not having. Getting my point?
Yeah.
Okay, so this is what the rule of exponents is. This is just one of the formula, which when we will be discussing the first chapter, number system, then we will be discussing this formula one more time. Okay, this is just one of the formula of exponent. So or if we are having just 1 by 2, and if I want to write this 2 in the numerators part, can you tell me, Sarah, what are we going to have?
2.
2. Exponent will reverse its sign. So what was the exponent over here?
There's no exponent.
If there is no exponent, shall we say exponent is 0 or 1? Which one? Is it 0? Is it
1.
1? It's 1.
1.
It's 1. Perfect. Okay. And when you are bringing it in the numerator, exponent will reverse its sign. Clear, Sarah?
Yeah.
Okay. Yes, your question now, if you in your mind, if it's coming that why it is not getting multiplied with 1, yes, 1 was already there in the numerator, it is getting multiplied with 1, but 1 into anything is just the same thing. That's why again and 1 I am not showing, just like the previous example. Getting it?
Yeah.
Now the question will be, this formula which we understood in detail, we are going to apply here. Now the question will be 1 by x to the power 3 plus x square plus 5. Is it a polynomial in one variable? So yeah, one variable we can
No.
see x is there. But is it a
Oh, it is.
polynomial? Is it a polynomial?
Yes.
Yes.
Yeah.
Is it a suppose like here the variable is sitting in the denominator. If we will take it in the numerator, can you tell me, Sara, what are we going to have? 1 by x cube. If I want to shift this x in the numerator's part, what can be written over here?
X to the power minus 3.
Minus 3 plus x square plus 5. Now tell me, just by observing this step, now tell me, is it a polynomial?
No.
It's not. It's not a polynomial. So whenever the question is it a polynomial, check it. Any variable is sitting in the denominator. If it is sitting, then apply the formula of exponent, which we discussed. Once you will apply, you will understand that no, it's not a polynomial. Okay. And suppose the same question, if I will customize the question, make it tricky, I will write like this: x to the power minus 4 plus 5. Is it a polynomial, Sarah?
Yeah.
It's a polynomial, because when you will bring this to x to the power 4 minus 4, which is sitting in the denominator, when you will bring it in the numerator, it will become, the power will become positive, and hence a whole number, and hence a polynomial. Got it?
Yeah.
Okay. Now, if the next example, if the question is like this: under root x plus 25 x square plus 3, is it a polynomial?
What does under root mean?
Under root means square root. Square root.
Oh,
Is it a polynomial? Now we
I don't
understand
know.
that. Okay. We understand that square root of x can be written as x to the power 1 by 2. Okay. Square root of 3 can be written as 3 to the power 1 by 2. Okay. If cube root of 5 we are having, then it can be written as 5 to the power 1 by 3. So square root, cube root, fourth root. If you are having fourth root, a teeny tiny 4 is written inside the square root. Okay, like this. If you are having, let's say, 25, and here a small teeny tiny 4 is there, that is representing fourth root. Here 4 is not multiplied. Okay, it is representing fourth root. The, like, there was a chapter, no, square root, cube root,
Yeah.
like this is what you have seen over there. Okay, is how to find the square root, how to find the cube root. However, we don't have to find the square or cube root over here. We are just understanding that whenever we are having square root, whenever we are having cube root, whenever we are having fourth root, we can write it in the power form, we can write it in the exponent form. How? We can, if the square root is there, if 2 is there, that means the square root is there, that in the power form it will become 1 by 2. If cube root is there, in the power form, in the exponent form, it will become 1 by 3. Okay. If
Yeah.
fourth root is there, in the power form, it will become 1 by 4. Okay. If we understand this concept, then now you tell me, is it a polynomial? Is it a polynomial?
No.
No, it's not. Why, Sarah?
Because the exponent is not a whole number.
Exactly, exponent will not be a whole number. 1 by 2 is not a whole number, because initially we discussed Whole number starts from 0 and all the counting numbers are whole number. So when we learn counting number, we have not learned we have not learned decimal number, fractional number, counting number. Okay, so 1 by 2 is not a whole number. That's why it's not a polynomial. Okay, however, this is a whole number. 3 is okay, but each and every term we will analyze, and then only we will declare that it's a polynomial or not. So it is not a polynomial. Is it getting clear, Sara?
Yeah.
Okay, so the exponent has to be whole number. That is one and only one criteria. If the exponent is a whole number, exponent of variable. Now you tell me, if we are having root 2 x square plus 5, is it a polynomial?
No,
Why?
because it's root 2. I don't know.
2 is there, but I said that the exponent of the variable has to be whole number. Any other term, the number, coefficient, constant, it can be anything. Anything is acceptable. So here, what is the exponent of the variable? Let me write it over here. Exponent of the variable term. What is variable over here, Sara?
X.
What is the exponent of x?
2.
Is it a whole number?
Yeah.
If it's a whole number, then it's a,
Polynomial.
got it?
Yeah.
Got it? So we will try making you confused, but you should not. Okay? The concept should be clear in your mind that exponent of the variable, only that you are going to check. Number can be sitting in the denominator. Okay? I am going to write like this: x cube by 2, 2 to the power 2, like that, plus x to the power 5, like that, then 4. And again my question will be, is it a polynomial, Sara?
No,
Why?
because when 2 goes to the numerator, it become minus 2 to the power minus 2.
But I said that coefficient can be anything, constant can be anything. You just have to focus on exponent of
Variable.
what is the variables over here? Shall I underline it? Variable, variable. What is the exponent of variable? Is it a whole number?
Yeah.
If it's a whole number, then it's a,
Polynomial.
yes, it's a polynomial. We are not going to get bothered by this 2 square in the denominator. Coefficient can be anything. Okay, number can be anyway. Only we are going to focus on the variables. Variables, exponent. Whatever is multiplied with the variable, that is fine. Whatever is sitting on the head of the variable, that we are going to focus on. Okay. So constant
Yeah.
number, coefficients, everything is perfectly fine. We are going to focus on the exponent of the variable. If that's a whole number, then it's a polynomial. Now you will find in your book that there will be a question like this: 2u square plus 3w plus t. Now the question is it a polynomial in one variable?
No.
Why?
There are 3 different variables.
Yeah, it's not a polynomial in one variable. However, the exponent of the variable is fulfilling the criteria, but here we are totally, completely focusing on polynomial in one variable. So one variable we don't have. Yeah, these are the all possibility we have discussed over here. This is how you will be getting question in your book, and you will be able to do that. Is that clear so far, Sara?
Yeah.
Now there comes the concept, that is degree of the polynomial. Degree of the polynomials. So degree of the polynomials means highest power of the variable. Highest power or exponent of the variable. That's called degree of the polynomial. So suppose we are having a polynomial. Let's say we are having a polynomial x to the power 5 plus x cube plus x to the power 4 plus x to the power 7. Now, what will be the degree of this polynomial? The highest power of the variable is the degree. Okay, so let's see what are the powers. Will you be able to say what will be the degree?
7.
Exactly. Okay, I can see you already understand highest power of the variable. So this is degree 7. If I am writing x square plus x, what is the degree of this polynomial, Sara?
2.
Perfect. If I am writing, for example, let's say 2y plus 3, what is the degree of this polynomial, Sara?
1.
Perfect. If I am writing, for example, a number that is just 32, is it a polynomial?
No.
Is it a polynomial? Yes, it's a polynomial. It's a polynomial. Okay. There, one more rule is there in the exponent. One more rule is there in the exponent which says that anything having power 0 is nothing but just 1. A to the power 0 is 1. 5 to the power 0 is 1. 10 to the power 0 is 1. 1000 to the power 0 is 1. So any number you write it and that's power 0 is 1. Now you must be thinking why I started explaining this one. If you understand this, that x to the power 0 is 1. Y to the power 0 is 1. A plus B whole having power 0, that means it doesn't exist over here. Result is, be careful, the result will not be 0, the result will be 1. So anything, any number having power 0, any variable having power 0, the result will be 1 only. Okay, so 32 we are having, we can assume it like this. We can assume that 32 x to the power 0. Why not? Because x to the power 0 is just 1, Sara. So 32 into 1 is just 32. So are we changing the number? Are we changing whatever is given in the example? No, we are not doing any drastic change. Okay, few things are there which is acceptable in mathematics. If you are just changing the representation, okay, if you are having a equation, let's say you are having a equation here 2x here y, so if you are adding same number on both sides plus 2, these are the things which is completely allowed in mathematics and we can do that anytime. Okay, similarly, if we are having a fraction 5 by 6, and here if let's say there is a fill in the blanks, a box is there. Can you tell me what will be there in the box, Sara?
10.
10 will be there. This is also one of the concept which is completely allowed in mathematics. If 6 is multiplied with 2, then we are bound to multiply the same number in the numerator also. Okay, if we are having a fraction and you are all of sudden you are multiplying a number in the numerator, then you are bound to do the multiplication of the same number in the denominator. Okay, so these are the thing which is allowed in mathematics. Okay, here also this 32 we are going to just change the representation little bit. We are going to change the representation, we are not going to do any change by ourselves. So 32 we can think like this, 32 can be written as 32x to the power 0, because x to the power 0, x to the power 0 result is 1 and 32 into 1 means 32 only. So are we changing the given example? No, we are not changing. Okay, now you tell me what is the degree, Sara?
0.
0. And whenever any number will be there, 32, 245, 232, is it a polynomial? You have to say that yes, it's a polynomial. Okay? Yes, that's a polynomial. Here we can't see any variable, so degree over here is 0. Okay? This is how you can always recall it. If you cannot see, suppose I am giving you an example that is 256 and I am asking you what is the degree of the polynomial. First you should know that yes, this is a polynomial. Okay, now the next question is what is the degree of this polynomial. So you can't see any variable over here. Degree means highest power of the variable. Is there any variable? No. So we can directly write, if since no variable is there, that means degree is 0. Getting it, Sara?
Yeah.
This is how we will always like recall it, but in detail, this is the concept. This is the concept that we are assuming that 32x to the power 0 or maybe y to the power 0, whatever you wanna take, you take it. Hence the degree is 0, because y to the power 0, anything having power 0 is just 1. Okay.
Okay.
So now I can see you are getting how to like find the degree of the polynomial just by observing the polynomial. You are able to say what will be the degree. Now on the basis of degree, we are having the name of the polynomial. So do you know when the polynomial looks like, what is the name of this polynomial when the degree is 0? Linear polynomial, quadratic polynomial. Do you know that?
No.
Okay, let me write it over here. No worries. So on the basis of degree, there are name of the specific particular name of the polynomial. Okay. So when the degree of the polynomial is 0, I'll be giving example parallelly. When the degree of the polynomial is 0, for example, now only we are discussing about the example, that is any constant number, 24. Here, what is the degree of the polynomial? 24.
1.
If I am writing just 24, Sara, what is the degree of
0.
the polynomial?
0.
Perfect. It's 0. Okay. And when the degree of the polynomial is 0, the name of the polynomial is, specific particular name of the polynomial is 0 polynomial. Or one more name is there, that's called constant polynomial. Okay. Now the other one, when the degree of the polynomial is 1, for example, let's say 2y plus 5. Here the degree of the polynomial is
1.
1, or maybe 3x plus 7. These are the polynomial having degree 1, and the name of this polynomial is linear. Why the name is linear polynomial? Because in future we will be talking about coordinate geometry chapter. You have learned?
Yeah.
Yeah. Coordinate geometry chapter, you will see that this, like, there only the concepts are there, how to locate the point, how to search the point. But previously there was a concept of graphing also, which is excluded now. So when we will plot the graph of these type of equation, then we will be getting a straight line. Okay. When we will plot the graph, which you will learn anyhow, you will learn in future, in like in the next class you will learn. So when we are going to plot the graph of this type of equation by using the concept of coordinate geometry, then we are going to get a straight line, and that's why the name is linear polynomial. Linear. Okay. We don't have to go that deeper. We just have to know that when the degree is 0, it's called 0 polynomial. When the degree is 1, it's called linear polynomial. When the degree of the polynomial is 2, for example, x square plus 2x plus 5, or maybe for example just x square plus 5, the here also degree is 2, or maybe for example just x square plus 2x. In all of the three examples, degree is
2.
2. And when the degree is 2, the name of this type of polynomial is called quadratic polynomial. Okay. When the degree of the polynomial is 3, for example, x cube plus x square plus 2. Okay. Or maybe for example x cube plus 25. Here degree of the polynomial is 3, and hence the name of the polynomial is cubic polynomial. Okay, cubic polynomial. Now the next one is when the degree of the polynomial is 4. For example, x to the power 4 plus x cube plus x square plus 3. If the degree of the polynomial is 4, the name is quartic polynomial. And this much only we have to learn. Quartic polynomial. Don't worry, I will help you memorizing the names.
Okay.
So see, when the degree of the polynomial is 0, it's called constant polynomial or zero polynomial. Okay. When the degree of the polynomial is 1, it's called linear polynomial. We can see over here. Example also I have given over. When the degree of the polynomial is 2, it's called quadratic polynomial. Quadratic. See carefully the name, it's quadratic. Okay, when the degree of the polynomial is 3, cubic polynomial is already, like you will be able to recall because cube root chapter you have done. Right, Sara?
Yeah. With cube root?
Yeah, previously in the previous class, cube, square root, cube root, these chapters were there, right?
Yeah, yeah. Yeah.
Yeah. So when the degree of the polynomial is 3, you will be able to recall. You will be able to connect that, okay, 3 means cube. 3 means cube. Yes or no?
Yeah.
Yeah. So when the degree of the polynomial is 3, it's called cubic polynomial. It's called cubic polynomial. And when the degree of the polynomial is 4, it's called quartic polynomial. So please don't get confused between degree 2 and degree 4 because degree 2, the name is quadratic. Quadratic and degree 4 is quartic. Okay. And this much only we have to learn, Sarah. After that, when the degree is 5, when the degree is 6, when the degree is 7, suppose in your exam all of sudden a question came that x to the power 6 plus x to the power 5 plus x cube plus x, what is the degree of this polynomial, Sara?
6.
6. And if the question is also asking us to write the name of this polynomial, then we will say it is degree 6 polynomial, because we don't have to learn the name after 4. Degree 6 polynomial. So when the degree of the polynomial is 4, till that, till this degree we will be learning the name, and after that degree 5, degree 6, degree 7, we will just call it like this, degree 5 polynomial, the way I have written. Degree 5 polynomial, degree 6 polynomial, degree 7 polynomial. This is how we are going to call it. And when you will call it like this, everybody will understand. Okay. Now if the question is like this, that x to the power, let's say 2x plus 8, what is the degree of this polynomial, Sara?
1.
1. And hence the name of the polynomial is, it is
Linear
it is
polynomial.
linear polynomial. Okay, this is how we have to name it. So at least till degree 4 we have to memorize the name. Just a second, Sara. Yeah. So far, is it clear, Sara?
Yeah.
Okay. So next concept over here is how to find the zeros of the polynomial. Okay. Before that, one more concept is there. Suppose I am writing a polynomial, Sara. Let's say 2x plus 5. Here, if I will ask you, what is the coefficient of x?
2 plus 5.
Perfect. 2 plus 5.
Wait, no, I meant 2.
Just 2, Sara. Okay. Coefficient means what is multiplied with x. And that is only 2. Okay. And in this, suppose I am writing the next question, that is 8x square plus 5x plus 7. Now the question is, what is the coefficient of x, Sara?
5.
Perfect. What is the coefficient of x square?
-8.
Perfect. Okay, we have to be clear with the sign also. It is -8. It is not +8. It is -8. So with proper sign, we will be writing the coefficient. Now here only, Sara, if I will ask you, what is the coefficient of x cube? Can you see any x cube over here?
No.
If we can't see any x cube, that means coefficient is 0. And this type of question also you will see in your book also, in your exam also. You will see that term you cannot see in your question, but if then also the coefficient of maybe x to the power 4, x to the power 5, x cube, it is asked in the question. So basically when you can't see in your polynomial, then you have to say that coefficient is 0. Okay, and what is the concept behind that? The concept behind that is we are assuming that that 0 into x cube is sitting over here. 0 into anything is just 0. So we are just thinking that maybe 0 into x cube is sitting over here. That's why the coefficient of x cube is 0. Are you getting my point, Sara?
Yeah.
So don't go that deeper. I would suggest you, when you can't see x cube, coefficient is 0. And if I will ask you, what is the constant term over here, Sara? Can you tell me what is the constant term in our polynomial number 2?
I don't know.
This is called constant, Sara. This is called constant. If just a number is there, that's called constant. Okay. So this 8x square, it's a variable. 5x, it's a variable. Okay. Only x is a variable. But since 5 is multiplied with that also became, the complete term became variable. So basically in mathematics, when we are having a number, suppose I am giving you one example, that today I have seen in my rose plant there are X roses. There are X roses. So I'm using the variable, right, Sara?
Yeah.
This X value is going to vary. It can be 5, it can be 8, it can be 10, it can be 20. So that's called variable. We don't know the X value and it can be anything. That's why we call it variable. But when I will tell you 5x, suppose the next day, maybe tomorrow, I'm going to tell you that there are 5x roses. Now 5x is a constant. Is it a constant? No, that's also a variable, because x can be anything. And if x will be anything, then 5 will get multiplied everything. If x is 1, then the 5x will give us the result only 5. If x is 2, then 5x will give the result
10.
10. Perfect. If x is 3, then 5x will give the result
15.
15. So x is varying, and due to that 5x completely is going to vary. That's why we say that whenever a variable is multiplied with a number, the whole became just a variable. So this is also a variable. Okay, variable means it is varying. It is varying. According to the value of x, it is varying. Okay. Now constant means just a number. I will give you a data. Maybe day after tomorrow, I am going to tell you that now today I have seen that there are 20 roses. So I am giving you accurate figure. Yes or no?
Yeah.
If I am giving you accurate figure, accurate, that's called constant. Okay. Now it will not change. That's called constant. So whenever coefficient of x, coefficient of y, coefficient of x square is asked, you can check it like this. These concepts you can apply. If you cannot see if in this question only, if I am going to ask you what is the coefficient of x to the power 4, we cannot see x to the power 4 in our polynomial. Coefficient is
Yeah.
0. Okay. Now the
Okay.
next one, what is the constant term? The constant The constant means just the number. Okay, that's called constant, and that is 7. Okay, Sara?
Yeah.
Just a moment. Let me take out few more questions from the book. Yeah. So this coefficient is clear, right, Sara?
Yeah.
Okay. Now the next concept is, suppose we are having a polynomial. Let's say px is equals to x square plus 2x plus 8. Okay. Now suppose the question is asking you to find p of 1. See, this is how we will represent the polynomial, by using this px, qx. So it doesn't mean that p is multiplied with x. It doesn't mean that p is multiplied with x. X is sitting in the bracket and p is multiplied with x. No, this is just the representation. This means that we are having a polynomial p, a polynomial p we are having where x variable is there, where x variable is there, or x variable used in our polynomial. That's what this px represents. Please don't take it like p is multiplied with x sitting in a bracket. No, it's just the representation of polynomial. We will represent our polynomial like this: q of y is equals to y plus 20. Qy is just the representation of the polynomial. Okay, we are having a polynomial q having the variable y. We are having a polynomial q which is having variable y. That's the meaning of the left hand side part. Okay, so this is how we will represent our polynomial. Now if a polynomial is given like this, let's say qy is given as, let's say, y to the power 3 plus y square plus 20. Okay, now if suppose the question is find q of minus 1, then what we will do, Sara?
Minus 1 to the power of 3 plus minus 1 to the power of 2 plus 20.
Yeah, you understand that already. I can see that whatever it is asking, suppose I am asking you find q of k, Sara, then can you tell me what will be the result?
Kq plus k square plus 20.
Perfect. This is how we are going to find whatever is asked in the question. Now the next part, that is zeros of the polynomial. Now we will see how to find the zeros of any polynomial and what exactly is the meaning of zero of the polynomial. So suppose we are having a polynomial. Let's say we are having qx is equals to 2x. Let me take a simple one at first. Suppose we are having qx is equals to x plus 5. Now the question is, what is the zero of the polynomial? Will you be able to find, Sara?
I don't know.
Okay, so zero of the polynomial means such a x value which will make everything zero over here. Such a x value which will make the complete result after doing the simplification, like addition, subtraction, whatever is given over here, the result will become zero. What is that particular x value? Is it 1? Is it 2? Is it
Minus
3?
5.
Minus 5. If we will be taking a minus 5 at the place of x, our result will completely become 0, and hence x equals to minus 5 is called the zero of the given polynomial. Okay, so let's find 0 of few more polynomial just by observing the polynomial. Suppose I am having a polynomial, let's say px is equals to, let's say x plus, or maybe x minus 20. What is that particular x value which will make the complete polynomial z?
20.
X equals to 20. Okay, is the 0 of this polynomial. So now you can understand 0 means x equals to 0. No, 0 means such a x value which will make the polynomial 0. Okay, 0 of the polynomial, and that particular x value is called the 0 of the polynomial. Now let's say, Sara, I am giving you a polynomial, let's say hx is equals to just 3x. Now you tell me what is the 0 of this polynomial, what can be taken at the place of x? Shall we multiply with 3 so that the result is 0?
Minus 3.
3 into minus 3 is?
Oh, I don't know.
If we are having just one and only one number which is going to get multiplied here, and the result will be 0, and that value is 0. If you will multiply 0 with any number, then only the result will be 0. Otherwise, the result will never ever be 0. So what is the 0 of this polynomial? Yeah, for this case, x equals to 0 is called the 0 of the polynomial. So what exactly is the meaning of 0 of the polynomial? 0 of the polynomial means that particular x value which will make our polynomial 0. Now that particular x value can be 1, can be 2, can be minus 1, can be minus 2. It can be any number. It can be 0 also. Am I making sense, Sara?
Yeah.
Okay. So